recording going. So straight line is a linear relation, okay? And it can be written as an equation. For example, this problem over here on the right-hand side of the page, it is the equation x plus y equals 8. So we can express a graph, an equation. That's a relation. It's a linear relation because the line, it makes a straight line with those ordered pairs that are created there. Standard form of an equation of a line is ax plus by equals c. A, b, and c are just numbers. X and y are the variables, like they've always been. A, b, and c are integers. What kind of numbers are integers? Whole numbers. So that means no fractions, no decimals. That's true. Whole numbers, positive and negative. Whole numbers are integers. And it says that a is greater than 1. That rule is kind of fluid depending on what textbook you're using, whether or not the a has to be positive. That doesn't necessarily always hold true for standard form. This particular curriculum does hold to that. Okay, so we'll address that some as we go along. And if you do some things on Khan Academy, there may be some things that it doesn't do exactly the same as this, and that's a philosophy thing. It's not necessarily right or wrong one way or another. The GCF of A, B, and C is 1. What's a GCF?
Greatest common factor.
Greatest common factor. What does that mean about those three numbers? A, B, and C. That you cannot do what? It means you cannot divide them all by the same thing, other than 1. Like if you had a problem that was 2x plus 6y equals 8. That looks like standard form. It meets all the criteria except for the GCF, because all three of those numbers could be divided by what? 2. So that you would divide them all by that number. Okay. So if we're looking at standard form, this may look like standard form, but it's kind of not. It's not because of the GCF that you could divide by. So you got to check to see if you can divide everybody by the same thing. And if you can, divide by it. If you can't, then maybe it is standard form. All right. So we're going to take some problems and write them in standard form. So we're going to get them into that ax plus by equals c form. Looking at number 1. It looks like it might already be there. But what rule that's given above does it violate? Divide them by what? Got to be all 3 of them. Can't just be 2 of them. It's got to be all 3. Okay. What rule is
A is less than.
Yeah, it's a negative number. So A needs to be positive to make this truly standard form. So, yeah, we can divide them all by 1, but what kind of 1 could we divide by and change the sign?
Negative.
The negative 1. So we're going to divide them all by negative 1. And that gets us 5x minus 6y is equal to 12. And that is now standard form. That the A is positive. A, B, and C can't be divided by anything else. There are no fractions or decimals in there, so we're good. No, you don't have to solve anything. You're just trying to get it into that form. That's one of the things with this lesson. It's kind of weird because you're not getting an answer. You're getting an equation in a particular form. Okay. So let's look at number 2. What form is number 2 in? It's in slope-intercept form. That's the form we've done the most work with in an algebra class. But we want to write it in standard form. So to be in standard form, you need to have what on the same side? X and y. So I'm going to move that x over. I'm going to subtract 2x. That gets me negative 2x plus y is equal to negative 9. Is that standard form? No. Same problem that number 1 had. Divide everybody by negative 1, and that changes the sign to 2x minus y is equal to 9, and there we have standard form. Look at number 3. That one's almost standard form. What's in the wrong spot? The C. So let's get rid of that 24 by addition. Get it over there. So we got 9x plus 6y equals 24. Is that standard form? Everybody's divisible by 3, so we're going to divide them all by 3. That GCF rule kicking in there. Now that, 3x plus 2y is equal to 8 is our standard form for that problem. Number 4 is like 3, so I'm not going to do it. Let's go ahead and go to number 5. Get those fractions in there. Everybody loves the fraction problems. All right, so remember the rule is that you can't have fractions or decimals in standard form. So we're going to have to get rid of those. So we've got to figure out how do you get rid of something over 4 and something over 3. Well, the key is look for what would be the common denominator between a 3/4 and a 1/3. 12. So what I'm going to do is I'm going to multiply this entire problem, every piece of it, I'm going to multiply by 12. Every single piece. That 12 is the common denominator for the fractions. That's what you want to use, is the common denominator for the fraction. So when I multiply 12 times 3/4, 12, it should be 9. Or 12 times 3/4, I divided, I hit the wrong button. 12 times 3/4. There we go. 9, that's right. This would be 9x. A third of 12 would be 4, right? Yeah, it'd be minus 4y. And then 12 times 1, I think we all got that. And that's right. You got to check all those other things, make sure that they don't do something there. And there we have standard form. But the key is getting the common denominator for those fractions. Okay? So look at number 6. It's got a fraction in it as well. See if we can get it in the right direction. What do we do? Yeah, you can do that. It's absolutely legal. 1/6x minus y is equal to -2. Don't forget that negative sign on the 2. That's the most common mistake there, is to drop that negative sign on that 2. And that'll mess you up every time, because you know the multiple choice is going to have the problem where it's got, instead of -2, it's going to have +2 over there. All right, now we got a fraction in front of x. 6. Perfect. So multiply both sides by 6. That's going to be x minus 6y is -12. And there's our standard form for number 6. Pretty simple. Again, stuff you've done before, but we haven't done as much stuff with standard form as you have slope-intercept form. So it's a little bit different. Sometimes standard form's kind of skipped over because you don't do much with it, but we use it a lot when we get into systems of equations. So I like to talk about it some, and I've seen a couple of ACT problems where all you had to do was put the problem in standard form, and that was the answer. And I'd hate for you to miss something that easy, because that's pretty easy, right? So that's a point on the ACT. So slope-intercept form. This is the one where it's in our wheelhouse. We've been doing this one for a long time. 7th and 8th grade math does a lot of stuff with slope-intercept form, graph a lot of lines and things. So linear equations in slope-intercept form, usually written y equals mx plus b. If we use the function notation that we talked about last week, it would be f of x equals mx plus b, where m is the what? Over run, or the slope. And b is the, what's b in those equations? Y-intercept. Good job. y-intercept. All right, now slope is a constant rate of change, so keep rate of change and slope are the same thing. So anytime you see a rate of change, or if it's a word problem and they use the word per hour or per month, yeah, go ahead. You good? Okay. So anytime you see slope or rate of change, or in a word problem you see the words per month, per hour, per day, something like that, that per is like a rate of change. You got to think that's slope. Okay, so slope is a constant rate of change between points, and you said rise over run. That's exactly how we want to think of it. And there are four types of slope. All right. The first type, I'm going to draw a little coordinate plane here. I'm going to draw it in every box. Just a coordinate plane. You don't have to put any marks on it or anything like that. But you just got a coordinate plane in each box. If the graph goes up and to the right, what kind of slope is that? Positive slope. If the line goes down and to the right, it's a negative slope. If it's a horizontal line, what kind of slope is that? This is where they get it's a little tougher to remember. Horizontal line. One's undefined and the other one's not undefined. Yeah. So a horizontal line is y equals a number. What's the slope of a horizontal line? It's 0. A vertical line is the undefined. Horizontal line is 0 slope. A vertical line is undefined slope. And it doesn't matter where that horizontal line is or where that vertical line is as far as on the graph. I just pick the place. Positive, negative, 0, undefined slopes. Being able to recognize those is going to help us, especially when we get to the stuff with the finding the equations of lines from data sets. All right, let's do a little graphing. We're going to graph with by hand, and then I'm going to show you on the calculator just how to check and make sure you're doing it the right way. So first equation is in slope-intercept form already. That's the easiest form to graph out of. That's why we've done so much with it over the years. So what is the y-intercept for number 7? 7. So I'm going to go to 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7. And then the rise over run, or the slope, is 2 over 5. But if I go up 2, I go off my grid. So how do I count that, Connor?
You can change both the numerator and denominator to negative.
Very good. So it's a positive 2/5, right? So the line should be going like this, right? So to get part of the line going the other direction, we go down to left 5. I didn't count 5. 1, 2, 3, 4, 5. There we go. And we draw that line. I have to make myself a straight edge here. Grades are good enough straight edge. Oh yeah. We got to get faster so we can get not too fast. There we got a line. With the calculator, with your graphing calculator, hit the y equals button, which is the top left button. I've got some stuff in there. I'm going to get that cleared out. I don't want to do that. And if you got one of these plots at the top, if it's darkened in, we need to turn that off because it can mess up your graph. Okay, so if one of the plots at the top is darkened in, just press the up arrow until you get up on those, and then to turn it off, you just hit enter, and it won't be darkened in anymore. And then if there's another one, you do that as well. Then press the down arrow to get back to your y equals. All right, now I'm going to type in that problem. I'm going to use the fraction button, 2 over 5 Then I'm going to press the right arrow key to get outside of that fraction and put the x beside it, plus 7. I'm going to hit graph, and you're going to see mine looks a little different because I was doing some graphs in college algebra. Yeah. Zoom 6. What you got? Alpha, and then the y equals what? The green alpha button. The green button up on the left, and then the y equals button. It'll pop up a little menu for you. N over D. That's the fraction button. Yeah. That lets you type in a fraction. That'll help you. Yeah, it's pretty neat. The 83s, if anybody's got an 83, they don't do that. You'll get there. We'll get there. All right, so we hit y equals. We typed in that fraction. All right, you want to go back up there to that problem. Press the up arrow. So you were down here at y2? You were like right here? Okay, so you go back up here and then press the right arrow key until you get to where you want to be typing. So keep pressing the right arrow key until you end up beside it. X, and X is right beside the green alpha button. There's a button that says X, T, theta, N, so, and then plus and the 7. And then hit graph. And if yours is not graphing it, hit zoom, which is the button in the center at the top, and then number 6. That will set your calculator to the standard window, 10 by 10.
Good job, Brian. It says error.
That's too decided for an error, ain't it?
Syntax error.
Well, how do you make it show a graph?
Clear that out. We got it now.
Oh my gosh.
Hey, that was a good one.
You get the denominator, press the right arrow. Now put your X.
I know.
All right, so we all have graphed a line with our calculator. That's wonderful. Let's graph that line for number 8. What changed? What's changed about number 8 compared to number? It says f of x instead of y. That's the same thing, right? Remember, they mean the same thing. So when I graph that one, my y-intercept is 2. My slope is -1. So down 1, right 1, down 1, right 1. Do that as many times as you prefer. A couple of times is what I usually try to do, just because it makes me a better looking line. And then on my graph, my calculator, I can hit y equals. And if I don't need that equation anymore, I just hit clear and it erases the whole thing. And I'm going to put -x plus 2. Be careful to use the negative symbol, not the minus sign. The negative symbol is down here by the decimal point, down at the bottom row. If you use the minus sign, it's going to give you an error. It does not read them as the same thing. Yeah, keep in mind, you can always graph things by hand. And you will have to graph some things by hand on homework and things. But the calculator is helpful to check with and to quickly get a picture of what's going on. And we'll use that. When we get to the higher degree polynomials, that graphing calculator is going to really help us a lot. You probably get the minus sign instead of the negative. That's what I'm guessing. That's what I'm thinking. Yeah, so go back to y equals. And then just hit clear. Right, and then the negative sign down there by the decimal, and the x plus 1. Now, yeah, that's it. That's just the common thing when you're first learning to use these things. They're a little different. All right, so we graphed 7 and 8. What about number 9? What's up with it? It's not in slope-intercept form. It's in standard form, yeah. So how do we get it in slope-intercept form? Subtract x. So we got 3y is equal to negative x minus 15. One more step. Divide everybody by 3. So y is equal to negative 1/3 x minus 5. So I know I could go 1, 2, 3, 4, 5. Down 1 over 3. I could go up 1, left 3 if I wanted. So to graph it with my calculator, I've got to get it in slope-intercept form anyway. You can also graph with intercepts by hand. Your calculator doesn't know how to do that. It needs it in slope-intercept form. It needs y by itself. It can graph a ton of different functions, but they got to have y by itself before it can do it. So, and again, you could type that into your calculator if you wanted to. Number 10 is just very similar. Nothing, no need to do it. Okay? All right? It's linear stuff the whole time. All right. Vertical and horizontal lines. So the equation of the vertical line on number 11, that's this line right here. When it's in black and white like that, it's hard to tell which one they're talking about is the line. The x and y axis, they mark x and y on for us. Alpha, y equals green button, and then the top button. Get out, and then the first one. All right. Where is that crossing the x-axis at? At negative 3. So that's the equation of the line. It is that simple. There is not anything simpler than that. You just got to memorize that fact. There's no really trick to knowing that. You just got to memorize. X is always negative 3, no matter what the y value is there. So it's x equals negative 3. On number 12 there, we got this horizontal line right here, this one. What's the y value that it crosses at?
1.
Y equals 1. Easy stuff. But it's a memorized fact. There's really no trick to it, no calculating to do. It's a memorized fact. All right? The next thing is parallel and perpendicular lines. Again, an Algebra 1 concept. I'm not 100% sure you did equations of parallel and perpendicular lines in junior high. I know you did them in Algebra 1. So slopes of lines that are parallel are what? Parallel lines have what kind of slopes? The same. They're equal. Parallel lines have equal slopes, the same slope. Perpendicular lines have slopes that are negative reciprocals.
When you make these videos, right? How do you do it to where you can hear you, but you can't hear us?
It's just where the microphone's right here, and it just can't pick you up. You're too far away.
But like, yeah.
It might pick. Yeah, probably. Please don't, because I don't want to have to spend another hour and a half making videos. All right, so what we're going to do here on these problems is determine, are they parallel, are they perpendicular, or neither, because they could be neither, which would mean they would cross at some angle. We don't know what angle. Parallel lines, remember, go the same direction. They never cross, never touch. Perpendicular lines, what's special about them from a geometry standpoint? Yeah, but what's the angle?
4 right angles.
4 right angles. That's what's so special about perpendicular, is it's 4 right angles. When you talk about building structures, you want your corners to be right angles because that's the strongest that it can be. So that's why all the buildings have corners, or most of them do. I won't say all of them. McNear Central doesn't have a lot of corners. It's round, but it's weird. Yeah. All right. So 13. If we want to compare parallel, perpendicular, or neither, what do we need from those equations? We got to get slope-intercept. Yeah, so we can get the slope really easily. So let's get them in slope-intercept form, and then we just look at the number in front of x. If it's the same, they're parallel. If you flip it and change the sign, it's perpendicular. If it doesn't do either of those things, it's neither. So we're get them in slope-intercept form. So subtract 10x, 5y is equal to negative 10x plus 5, and then I would divide by 5. So y equals negative 2x plus 1. And then, yeah, negative x minus 16 is equal to 2y. Divide by 2. That's negative 1/2 x minus 8 equals y. The things we're comparing are the slopes. Is it?
Yes, sir.
They're reciprocals,
No.
but they're not negative. They're not opposite signs.
That's what I meant.
So that's a neither. Yeah. Hopefully you worked it right on your paper, though. Got to be careful about the negative reciprocal. Flip it, change the sign to be perpendicular. Okay. Let's do 14. Get them in slope-intercept form. So negative 6y is equal to negative 8x plus 42. Divide by negative 6. Y is equal to 4 over 3x minus 7. The minus 7 doesn't matter. Then I'm going to divide this one by negative 3. And that's going to be y is equal to positive 4/3 x minus 3. Slope. Those are parallel. You know. What about number 16, the one right below that? Those are not in, you can't get those in slope-intercept form.
It would be perpendicular.
Why?
Because they're straight lines.
Yeah, well, they're all straight. All 4 of these problems are all straight lines. But one's a horizontal line and one's a vertical line. The x equals 2 is a vertical line. The y equals 2 is a horizontal line. Horizontal and vertical are always perpendicular to one another, so that is perpendicular. In geometry, you guys remember this symbol from geometry? The upside down capital T. That means perpendicular. So on your homework, if you want to write the upside down T instead of writing out the long word perpendicular, I'm fine with that. Parallel, it's 2 sticks straight up down like that. That's the symbol for parallel, and I'm okay with you using those symbols. Just know what they mean, because the quiz doesn't use those symbols. All right. Next thing, x and y intercepts. Again, Algebra 1 stuff. The point at which the graph intersects the x-axis is called the x-intercept. The y-intercept's where it crosses the y-axis. Identify the x and the y-intercept in this picture that's on the right. What's the x-intercept? What's that ordered pair? Negative 3, what? What's the y value? 0. That's the x-intercept. The y-intercept would be 0, 4. Good job. All right, so easy thing there. X-intercept is also referred to as a root. a zero or a solution. As we go further into more Algebra 2-ish stuff, we'll use these words more when we talk about x-intercepts for quadratics, will be the next thing we go to. And we talk about x-intercepts for higher degree polynomials, we'll talk about them being roots, zeros, or solutions to the equation out of that. All right, so let's talk about finding some of these intercepts algebraically. Algebraically means working it out, not looking at a graph. That's all that means. All right. So find the x-intercept of an equation. Set y equal to 0. So it tells you right there what to do, and solve it for x. To find the y-intercept for an equation, set x equal to 0 and solve for y. Whatever intercept you're finding, that's the letter that's left in the problem. If you're finding the x-intercept, the x is left in the problem. If you're finding the y-intercept, the y is left in the problem. Okay, whatever letters in the problem still, that's the intercept you're finding. So for this example, we got y equals negative 2x plus 5. Let's find the x-intercept. So we're going to plug a 0 in for y. 0 equals negative 2x plus 5. Subtract 5. Negative 5 equals negative 2x. Divide by negative 2. Be 5 over 2, 0 would be the x-intercept. I'm writing it as an ordered pair. I would rather you keep it as an improper fraction. If you were going to graph this, if I were asking you to graph the x and y intercepts, then yeah, I would say think about it as 2.5, because you know we're 5 over 2. That doesn't mean it's much to us on a graph as 2.5 does. But if we're just finding that intercept, leave it as an improper out of that. Y-intercept, this particular equation is in slope-intercept form. So we really could use the shortcut and know that, hey, it's 0, 5, just because we know slope-intercept form. But you get the same answer if you plug in a 0 for x. The 0 plus 5 is 5. So you get 0, 5. If it's in slope-intercept form, I do not expect you to do that work. I expect you to know, hey, it's 5. So it's 0, 5. I hope that that's what you do. All right. So let's look at a few of these. We won't do very many of them. It asks us to find the x and y intercept for each equation, then graph it using the intercepts. We can also check the graph using our calculator by putting it in slope-intercept form and graphing it too. Okay. It should be the same picture. All right. So let's look at this one, number 1. What's the x-intercept? Or how do I find the x-intercept? Look, yeah, 0 for y. So 5x minus 1. We plus 1. 1 equals 5x. Divide by 5. You're right. And we get this fraction, 1/5. Where is that on the graph? Closer to it, right? Yeah. So it's going to be like really, really close to 0 there at the origin, but it's just to the right of it, 1/5. So we got to estimate where that's at. Okay. And then for the y-intercept, we know that the y-intercept, because it's in slope-intercept form, it'd be 0, -1, right? So that's that point. And we could draw a line connecting those dots out of there. My straight edge I made. And there's the equation of that line. If I were to graph that with the calculator, 5x minus 1, that looks a whole lot like what I just drew. It's the same thing. Should be the exact same picture. Okay. The difference is finding those ordered pairs first instead. All right. Let's jump down to number 6. Okay, let's do number 6, and then be done with this packet. All right, so that one's got fractions in it, and that's always a fun thing. So we're going to still find the x and the y-intercept. So I'm going to find the x-intercept first. How do I find an x-intercept? Put y 0. So 3/4 x minus 1/3 times 0 equals -2. We know what happens to the 1/3 times 0. It creates a 0, but it really just goes away, right? Now, how do I solve that equation? Good job. Multiply by the reciprocal. There's x, and then that'd be -8/3. So the x-intercept is at -8/3, 0. When I'm going to graph that, I need to, like Connor asked earlier, can I think of that as a decimal? Yes, think of it as a decimal. What is -8/3? -2 point.
Almost there. 2.6.
Yeah, it's about 2.6, 2.7, depending on where you round. Okay, so -2.7 is almost -3. It's a little better than halfway. So I'm gonna put my dot right there. That's my x-intercept. Let's find the y-intercept. So I'm gonna plug a 0 in for x. 1/3. Yeah, -1/3 x equals -2. I'm gonna multiply by -3 on both sides. Reciprocal of -1/3 is -3. So it'd be +6. That should be a y. Sorry about that. Wouldn't be a normal day if I didn't make a mistake. Those are y's. That's a y. So our y-intercept is at 0, 6. Go up here to 6. 1, 2, 3, 4, 5, 6. And connect those with a line. Straight line for no straight edge. Again, you can still get that in slope-intercept form. This is the same equation that we had done earlier to get in slope-intercept form. And you can graph that and make sure it's the same picture. Okay, sure of that. All right. Any questions about this part so far? Nothing. All right, that should be the end of that packet for you. Right.